Hello, this is Nitin Dahad with EE Times. I'm talking now to Lars Reger, who's the CTO of NXP Semiconductor. And Lars, hello, how are you?
Hi Nitin, hey, thanks as always, doing very well, deep in the technology.
Yes, I mean, ever since I first interviewed you, I think you're just the most passionate person in technology right now, and ever since I've been with EE Times.
Thank you, yeah, I believe what I'm doing, yeah, and I'm dreaming a lot.
So, we're here for automotive, you're going to be speaking about stuff automotive, but just tell us a little bit about some of the key developments at NXP over the last few weeks, and then we'll launch into some of the real things that you're doing, including some of the drone stuff and the robotics stuff.
Yeah, so honestly the amazing thing is that we chatted about it in the last years, the overall trends are not changing. So basically this trend for robotics, the famous sense, think, connect, act, safety and security, building trustworthy agents or trustworthy robots that take over responsibilities from us and act on our behalf. That trend is unbroken. That is a very, very old story. And the only thing that is happening, of course, every year we are crawling or jumping in bigger jumps towards that final goal of building these famous 50 billion smart connected devices, smart connected robots there for the industry. Yeah. And we are on that way. Yeah.
And what are the things I think you're seeing right now in that sort of whole robotics space? I think it's broader than robotics because it sort of stems from all that bringing everything down to the edge.
Yeah, so what you have seen over the last years, there is an enormous hype on AI, and there is perceptive AI, so how do I detect better that there is a human being in a picture? There is generative AI, there is people talking about agentic AI at the moment, and there is this belief, and this agentic AI is helping us building the agents. And again, the nerds have to crawl in now into that picture and have to say, AI is one part of the ingredients. It is required, but it is not sufficient. So you need to have low power architectures. You need to have trust in your robot. So safety and security built in. And how do you bring all of that together in a way that you don't need nuclear power plants to operate the cloud and to do loads of compute in an inefficient way? And we are building units at the moment up to 40, 100 teraops, below 10 watts, on such an i.MX 8 microcontroller with an AI coprocessor, and then of course the right safety and security architectures around to run small, large language models, below 10 billion parameters, but sufficient for most of the devices, smart fridge, X-ray system, all of your appliances at home, smart enough to run all of them. And then the key question again is, how do you make sure that they can live on a battery for years and don't turn against you, so are safe and secure and reliable?
Well, I mean, we've been talking about, maybe for over the last 12 months, about the small language models. And I think what I'm seeing when I travel around the world talking to people is there's lots of models specific to specific things now. We're
absolutely.
I interviewed somebody in Dubai, an AI company, and they're doing all that sort of language recognition for the Arabic language on a CPU.
Right. Yeah. I mean, this is maybe a new business that is coming up. 3 years ago, there was always this discussion. Yeah, but if you don't have the data, if you cannot train in millions of hours, you don't have a model. Today, you are going to open source platforms, to commercial platforms, and you're acquiring the model, download it, which brings another complication because you want to understand how trustworthy is that model. Is that model really trained with the right data? Is this model getting schizophrenic or reacting in an erratic way? So everything of that requires new testing or new verification, requires new trust, a little bit like for us human beings.
Yes.
I want to know what's your education to understand whether you should be the pilot or the driver in my car or better not. Yeah.
Exactly.
So these type of things are relevant for these agents as well. So there will be new business models. How do you prove trust? And that requires hardware, software, middleware from trusted providers. There's a reason why we bought TD Tech Automotive for this middleware. But to bringing all of this from a trusted source with trusted partners into that ecosystem, while it is, again, low power, safe, secure, trustworthy. that will be the industry enablers for the coming years.
Now we're talking about mobility. We're at a car technology show here,
Right,
and
yeah,
you're speaking at one of the affiliated shows. What are the things you're seeing right now that are real in autonomous or ADAS, and what are the things that are still aspirational?
Well, the things where, of course, we have to push the boundaries of physics is on the one side, I need to make the robot seeing better or having better sensors than Lars, the driver. So in other words, I want in rain, fog and snow to be my radars at the level that I can spot living objects far ahead of me.
That's sensing.
The sensing. I want to have sharper eyes than an eagle. I want to have better ears than a human being. So just better sensors to make the robot the better driver. That is one thing. The other part is I want to have this ultimate level of functional safety and security, even if the main brain is asleep. So if that car is parking, if that car is standing somewhere and so on, the infrastructure, the form factor of that robot still needs to fulfill certain life cycle functionalities.
Right. Yeah.
You need a lot of silicon, for example, from NXP. And then you have this driver replacement functionality, the big brain, where again, you have to focus on how do you architect your big brain to make sure that the brain cannot be distracted. Which part needs to be real-time, like in your cerebellum and your brainstem, where you have your reflexes and your real-time body functions. Yeah. Which part has to be the creative part, like in your cerebrum. So these different architecture discussions are getting of paramount importance, and this is why just building the trustworthy robot takes more time that Wall Street Journal and other newspapers in 2018 had postulated, where they said, okay, by 2020 we are done with that task. Yeah.
So, talking about 2018, I think that's one of the first times we had a conversation, I think, electronic or embedded world. And one of the things you said is, your customers are looking more for reference solutions and like going up the stack. We've seen that now a lot over the last 6-7 years.
Yes.
But what are the big challenges now for your customers? Because I guess they're not talking really chip level anymore. They're talking system level. They're talking software, and sometimes even they don't have any knowledge. How are you interacting with your customers now?
So I see us much more building at the moment sort of reference designs. Of course, we are a chip maker. We want to sell chips and best case software, but I have to show to my customers what these systems really can do. So ideally, in that use case that we talked about, we had an i.MX from our side. We have an AI accelerator chip. We show on a little PCB for an 8-watt unit what this thing can do. For radar, how is your best reception, best resolution doable? How can you realize it? And we are much more building these reference designs and bringing partners in and say, okay, now can you take this and customize it for your purposes? Not anymore like, okay, I throw a couple of chips into the game and someone brings software and someone brings a PCB. That usually does not work anymore. So this system discussion is very important, and very honestly also, if you want to discuss functional safety, you have to look at it from a system level first, and then you skin that thing and say, okay, the system has certain redundancies. This chip is the watchdog for that one. Which software platforms do I need? How do I have structural dissimilarity, that if I have a structural mistake, that I can overcome that? But this is all system level discussions, and only from there then you're diving into which transistors do I need in which place. Yeah.
Let's close here. So one of the things, we could talk forever, and I love talking to you, but over the next 12, 24 months, are we going to be having a different discussion, or are we still going to be talking about AI and agentic AI and all that? Are we going to move on from being those sort of esoteric type discussions and be a little bit more practical?
You will see maybe a bit more demystified discussion. So what I have here in my hands, this is one of our little i.MX 8 microcontrollers, and this unit here is a complete drone control unit. Now, this little device can operate a complete drone, or the motors, or the steering, and it has a tiny AI accelerator, only 2 teraops on board, to make sure that if you are losing your RF remote control, that the camera can fly the drone and can bring it home, or can bring it to the landing place, or do certain jobs. So these type of things, how do you build now embedded systems, in our old language, embedded systems that have AI, so smartness, safety, security, and low power capabilities, and that in a miniaturized factor. That is what you're going to see over the next 12, 24 months. And I could go from here now into zonal architectures of the cars, of course, into central compute of the vehicles, into car access. I mean, challenge me on all of these functions. We have a reference design on the shelf where I can say, okay, now this is the software platform that I would recommend. This is the power consumption that I can achieve.
Yeah.
And this is the level of AI that you need for a certain task.
Well, Lars, we can talk more on lots of those in future, but thank you very much for that.
Latest at CES, I try to provide you an update, and that is in 4 to 5 months from now.
All right.
Thank you,
Thank you,
Nitin.
Lars.
Thank you.